the case, then you can't do it, right? So I'm just going to draw a little picture. So I'm coming up with this on the spot. I don't have any examples right now. That's okay. Okay, so let's see. The graph is connected, right? I can get from one vertex to all the other ones. No matter where I start, I'm going to be able to get everything. But the problem is, see, if I look at these two vertices, these are odd. They're odd. But an Euler circuit has to be even, right? All the vertices must be even for an Euler circuit. So we can't really use it, right? We can't, this is not Euler, right? Not all vertices are even. So not Euler. That's how strict it is. Let's see if I can find another example here. Let's see, which one do we have here? See if I can draw the picture. So this one's from the video. This might help me. So I'm just kind of drawing it out since I don't have any examples with me right now. Doesn't have to be perfect, just to give you the idea here. Okay, so these points are, again, vertices. So everything that I made dark here is considered a vertex. Okay, so let's take a look at what an Euler circuit is. There's some other things that we need. So it has to be a path. So a path means that I should be able to get all the edges, right? An Euler path contains all the edges of the graph. No edge can be repeated. And I should be able to start at one vertex and get back to the same vertex. So it begins and ends at the same vertex. I should be able to find something that gets me that. So let's say I start with this one over here. So we're going to start and finish with this guy, if possible. So let's go around it. So I'm just kind of going along like this. See? Just like that. See? Now, what do you notice? See, I started at the same vertex and I got every single edge. No edge is left out. We didn't repeat any edges, right? We were able to go through this whole thing without repeating anything, right? We didn't repeat anything. Nothing got repeated. So this is an Euler path which contains, all the edges, right? We started at the same vertex. We ended at the same vertex. So yes, this is an Euler circuit. Before we can actually say, we can't just say that yet. We have to also see one other thing. So we also said that they have to all be even, right? All the vertices. Let's see if all the vertices are even or not. Well, you can see that these are even, right? There's only two going in. So there's two going into this one, two going into that, two going into that. How about this one? How many do I have going in? 1, 2, 3, 4, 5, 6. This one has 6. See? 1, 2, 3, 4, 5, 6. This one has 2. This one has 2. See, this one has 1, 2, 3, 4. 1, 2. So every vertex is even, right? So it contains all the edges exactly once, and every vertex is even. Each vertex is even. That's important. So yes, because those two conditions are both satisfied, this is an Euler circuit. Okay, so this is a good example that demonstrates an Euler circuit. Any questions?
Professor,
Yes.
for the first one, since it's not a Euler circuit,
Which one?
how do we list out the path?
The path?
Yeah.
Okay, so we can list out the path. So the path, it means that it contains all the edges of the graph. No edges can be repeated, but the vertices can be. So let's see if I can list out even the paths here. So I don't think I can get all the paths because see, if I go like this, what's going to happen? Well, maybe I might be able to. So yeah, it has an Euler path, but it's not a circuit though, because again, the vertices are not all even. So yeah, this is an Euler path because you can list out you can get all the line segments without going over any one line segment more than once. So here, A to B, B to D, D to A to C, C to D. It's not a circuit though. That makes sense?
So it's an Euler path because you can trace all of it in one go, but it's not an Euler circuit because it's not even edges.
Correct. So yeah, so I can find an Euler path because again, I can get all the edges, and I can, I'm able to get all the edges basically, but I can't. But they're not all even though, the vertices. That's the problem. So an Euler circuit has to be even, and it has to contain an Euler path, which means that I can't repeat any of the edges from above. You see? That's the difference between the two. Let's see. Let's try another one. So here's another problem we can do. So I'm trying to draw at a certain